Alright, so this is just the plain old solving triangles. So the second part of the assignment does have some easier problems in it. So solving right triangles would be part of that. So I just quickly do two of these, I guess. So if you are given the following information, then this is how I would set up the problem. I usually put the angle that's given down here. Okay, so if that's 22 degrees and C is 10, and C's got to be the right angle, then if that's 10, then this is sort of the way that the triangle might look. Okay, so what parts do I still have to find? Well, I have to find this angle, so that's going to have to be B. So how do you find B? Okay, so that's 68, right? So that will be easy. And then how can you find either A or B? Keeping in mind that you're given the 10 and you're given this angle. So to me then it becomes this problem, or not this, it becomes this kind of a problem. I went ahead of myself there. So looking from angle A, if I want to find side A and I want to use the 10, A over 10 is what for angle A? Opposite over, so the sine of A would be this, right? And you have A, so you can solve this. So then put it over 1. So then A is 10 times the sine of, and A was 22. So there you go. Now some books will teach that sort of as a formula, that A is always the hypotenuse times the sine, and I don't really stress that. Now if you have it memorized, good for you. You can certainly use that, but that's just more stuff I have to put in my memory, so I don't really want to memorize more stuff. So I think just writing a triangle or drawing the triangle is just as quick as trying to do it all from memory. Okay, how about B then? B would be A. To find B, you would find cosine, right? So the cosine of 22 is equal to A over, or to B over 10. So do you notice that B is found by using a cosine? And that always happens. So B would be 9.27. Okay. Could I have found B by using Pythagorean theorem? Probably, but again, the reason I don't is because Pythagorean theorem would also use the value for A, and this is sort of a rounded value. So I prefer using this, and it's actually more efficient. So, but it is possible. So how about this one? Well, if B is given an A, so I'm given angle A again. So, there's A. A is 40. Well, that looks a little bit more like this. And if B is 8, then that would be the side that is 8. Okay, so I like to draw the triangle again because it helps me figure out how to set up my proportions. So how can I find A now? A is opposite over if I want to use the 8, I need to use opposite over adjacent, right? So to find A, I have to use a tangent. So the tangent of 40 degrees would be A over 8. So here when you cross multiply, it still works out. So A would just be the tangent of 40 times 8. I wrote that in the wrong order a little bit. So that would be 6.7-ish. Guess I forgot to find B, right? Should have done that. Guess we'll do that last. And then how do you find C? Well, again, I want to use the 8. So 8 is an adjacent, so this would be the cosine of 40 degrees would be 8 over C. And then here's where it's a little bit different, because if you think of this over 1, then the C and the cosine of 40 just switch spots. So C would be 8 divided by the cosine of 40. Okay, and this is why I still write the proportions, because, you know, most of the time you end up multiplying all these things, but every now and then you get one of these where you need to divide. And if I don't write the triangle and actually look at the proportion and write it down, then I feel I'm more likely to make that mistake. So that would be it. And then I need to find angle B still. Well, that's 50. You can sort of see that. So that would be solving right triangles, just plain and easy. So you got a bunch of those actually. You got 15 through 23, I think, where you're given some information and you need to find the other parts. Are we okay with this? Alright. So hopefully that was most of the review. Now let's look at something new. So degrees can be measured into a different notation. This is a slightly older notation, but we're used to seeing decimal degrees. But we can use what are called seconds, or minutes and seconds. Okay, and the symbol for the minute is one of those, and the symbol for a second is two of those. So 4.5 degrees could be written as 4 degrees and 30 minutes. Okay, now I'll try to explain this a little bit better when I convert it. So how do you go from degrees then that are given as a decimal degree, so this is a decimal notation, which is what we need to use a calculator, right? How do I go from there to something that is in degrees, minutes, and seconds? Okay, so this is the way you do it. So the first part's going to be the same. So we have 12 whole degrees. Okay, and then plus, we have 0.278 left. So minutes and seconds sort of reeks of like 60s things, right? And I did say over here, a minute is 1/60th of a degree. What I'm trying to tell you is that 1 degree would be 60 minutes, and I wrote it the other way. So 1/60th of a degree is 1 minute. So these are your minutes, and these are your degrees. So what you need to do here is you have 0.278 of a degree, so you multiply that by how many minutes are in 1 degree?
60 minutes.
60. And then you get a calculator and you see what you end up with. Just do the, don't do the plus, do the 0.278 times 60, which is 16.68. Whoa. So this is, just this part is 16.68. So then I can write this. I have 12 degrees and I have 16.68 minutes. Well, there's a decimal in here still, isn't there? And we can go one size smaller. So what I mean with that is that 1 minute, how many seconds are in a minute?
60.
Is 60 seconds. So this can be split up into 12 whole degrees, 16 seconds, or minutes, sorry, plus 0.68 times 60 again. So then you do 0.68 times 60 again, and then that one, when that one comes out with a decimal, you get to leave it. So this is one reason I don't really use this, but there are word problems that do, so you sort of have to be familiar with it. So this is 40.8, 40 and then 0.8 of a second. So 12.278 degrees is the same as writing 12 degrees, 16 minutes, and 40.8 seconds. So this is an annoying conversion. Okay, I try to stay away from these, so I won't do this on a test or a quiz to you, but I might give you the other one. So sometimes you are given word problems where the measurement is given in minutes and seconds, and to convert that one, it's actually a one-step problem. It's a little bit easier, but I wanted you to at least see both of them. So we'll do this one. So this one you'll see here in the word problem in just a second as well. So how do you convert this? Well, this way. So this is 12, and then what do we have? We have 12 minutes, right? And how many minutes are in a degree? So this is plus 12/60th of a degree, right? And then the next one is minutes, right? I mean seconds, yes? And so there are 60 times 60 seconds in a degree, so you also get this, plus 52 divided by 60 times 60. Now that just goes in the calculator in one step. So this one's a lot nicer when you are asked to convert from minutes, degrees, minutes, seconds to decimals. You can just do it all in the calculator in one step. And so this one ends up being 12.214 repeating. So 12.214 2, 1, 4, and we can show repeating. So that's the decimal equivalence of what was given to us there. Are you guys okay with this? Alright, well, I'll do one more of these because you're going to see a couple of those, at least one, and I think maybe two in your word problem. So here's a word problem where unfortunately they gave us the angle, and you can already see it, this long notation here. So that is not the notation that we want. We want to use a decimal degree here because we need to put this in our calculator, right? So one of the conversions, that's something that I definitely have to do. So to convert this, so to convert angle A, I need to do 2 degrees plus, the first one's over 60, right? And then the next one is, there are 60 times 60 seconds in a degree, so then you do this. And you put that in your calculator and you see what you get. So that's actually 2.2 degrees. 2.23 degrees. Okay, that's not too bad. Alright, so now let's look at the word problem. So it says you're at the top of a mountain 3 miles above sea level, measures an angle of depression. So the angle of depression, so this is the angle that they gave us, right? So it looks way more than 2.23 obviously, but that's 2.23. To the ocean horizon. Use this to estimate the radius of the Earth. How in the world do I do that? Any ideas? Yes? No? Alright. If that's 2.23, then how much is this angle here? That would be 90 minus 2.23, right? Okay, which would be 87.77. Okay. But if this one's 87.77, how much does this one have to be? Well, what do you get when you do 90 minus 87.77, if I did my math right? Yeah, you better get 2.23 again, right? So this angle is actually also over here. Are you guys okay with that? Alright, based on this angle here, what ratio am I interested in? I have an adjacent side and a hypotenuse, and that would be a adjacent over hypotenuse is a cosine. So the cosine of 2.23 is r divided by r plus 3. Yes? Okay, it's the radius plus the 3 more. Well, how many variables are there? How many unknowns are there? Only one, right? Just r. It's in 2 spots, which is annoying, so I can't just solve it by plugging something in the calculator right away. But the cosine of 2.23 is worth something, so I can solve this by just cross multiplying. And hopefully you're now sort of starting to see a pattern, because this looks a lot like some of these other problems, right? But finally here's a problem that doesn't use the tangent. So then you multiply that one across, so it's r, or you distribute it. And then this is an r, that looks like a 1 now. So this thing needs to go over here, so I can just subtract it. Still good? And then r is common, right? Because it's here and here, so you can factor it. So when you have r and you take r out, so r divided by r leaves you a?
Negative 1.
Well, it leaves you a positive 1. On the first one. On the second one it leaves you negative 1, yes. But that one's a little easier to see, that you still left with the cosine of 2.23. So, but I don't want you to forget this one. That's an important, sort of a placeholder, but it's really needed. If you don't use it, you're really not going to get the right answer. And then you can find out what your radius is by doing what? Dividing by that mess. So here's what goes in your calculator. This thing goes in first, and you can hit enter, especially if you have a scientific. Then you do need to use brackets here, and then you do 1 minus the cosine of 2.23 in brackets, and you divide that into what you just came up with. So Again, we're trying not to round too early. On this problem especially, you would have had a wrong answer if you would round too early. So if you put in the cosine too fast, you're going to get something that doesn't really work. The reason it gives you such a wrong answer is because ultimately this answer needs to come out as a rather large. So a small mistake gives you a big difference at the end in the radius of the Earth. Okay, so that's the answer. And what unit, probably? In miles, right? They did give us miles here, but does that make sense that the radius of the Earth could be almost 4,000 miles? Okay.